So section 8.4, we're going to test claims of sigma, which is your population standard deviation. Now I sent you a handout that should look like this. It says tests for variance, but variance and standard deviation are pretty tightly related. One's just the square of the other. Now there's a couple assumptions for this test, just like there was for our previous tests. One that we generally can't handle in this class, that is it a simple random sample? But the other one we can look at and really should look at, and that is that the population being sampled is normally distributed. So right here, now this is actually a pretty strict requirement because this test is very sensitive to departures from that assumption. It's not something that you can correct with a large sample size. Back in section 8.3, if we had a large enough sample size, hey, we're golden. Not so much here. So you have to check that. You can check that with StatDisk. You go to normality assessment, check that there. But other than that, a lot of the flow of this is going to be the same as it was before. State your null and alternative hypothesis, decide on alpha, and then depending on how you're going to do this, you've got one of two choices. Now I'm going to suggest we do this with p-values. So step 3 is just going to be enter your data into StatDisk. And then step 4 is going to be to find the p-value. Now based on the p-value, if the p-value is less than alpha, then you're going to reject H0. If it's not, then you fail to reject. So, okay. And then finally state your conclusion in words. So let's look at example A here. There's a lot going on with this one, and it might take you a minute or two to read through this and kind of catch all that's going on in order to perform your hypothesis test. So the piston diameter of a certain hand pump is 0.7 inches. The manager determines that diameters are normally distributed with a mean of 0.7 inches and a standard deviation of 0.003 inches. After recalibrating the production machine, the manager randomly selects 23 pistons and determines that the standard deviation is 0.0022 inches. Is there significant evidence for the manager to conclude that the standard deviation has decreased at the 10% level of significance? Wow. So there's a lot going on there. But what I would suggest we start with is, what's the original claim? What are we testing in all this? Well, I've kind of tried to highlight that. I'll give you a hint, it's in green. So let's see if we can't figure out what that original claim is. The original claim is about a standard deviation. And we want to see if that's decreased. So that original claim would be sigma is less than what? Now that's a good question. What's it less than? Well, you've got two choices. There's 0.003 inch and there's 0.0022 inches. But I've kind of noted for you here what that 0.022 inches really is. That's the standard deviation from your sample. What we want to do is compare that to the old standard deviation, which is this one, 0.003 inches. So this original claim amounts to this, that sigma is less than 0.003 inches. Now let's put that in as part of a hypothesis test. As with many of our hypothesis tests, we're going to start out by stating the null and alternative hypothesis. So HO and HA. Where does this one belong? Part of the null hypothesis or the alternative hypothesis? Someone out there want to make me look good?
Alternative.
Alternative, perfect. So sigma is less than 0.003. The null hypothesis is going to be sigma is greater than or equal to 0.003. Now that greater than or equal to is not something you're going to see on my math lab. For them, it's just going to be 0 or equals 0.003. Okay. Did anyone catch what level of alpha we should be testing this claim at?
0.001.
I think it was a little bit bigger. Is it 0.10? Yeah, I think if you look down here, it's 0.10. 0.001 is very common. 0.10 is big enough that it almost makes me feel uncomfortable. But this is just an example in a textbook, so let's go with it. All right. Step 3, we're going to need to input some data. And before I tell you how to input that data, let me tell you where. In StatDisk, you're going to go to what's soon going to become your favorite, or at least most frequent, place to go, which is analysis, and then to hypothesis testing, and then to standard deviation, one sample. But when you get there, there's a couple things you're going to need. Either you're going to have the data, or you're going to need both of these things. The sample standard deviation and the sample size. So let's look back at the problem and pick up both of these. So what's the sample standard deviation for us in this case?
That would be 0.0022 inches.
Perfect. Now the problem that you're going to run into at home is deciding, well, which one of these is the population standard deviation, which one is going to be the sample. I guess the hint here for you is that you're selecting 23 of these pistons and determine that the standard deviation is 0.2 or 0.0022 inches. So that's your sample right there, which is why this is our sample standard deviation. And then the 0.003 that we had over here, that's our population standard deviation, or what we're going to use as part of our hypothesis test. Now, I hope I didn't gloss over the fact here that we have a sample size of 23. So let's put that into StatDisk. Analysis, hypothesis testing, and standard deviation one sample. All right, so significance level, that was a rather large 0.10. Ooh, you know what? Before I even do all that stuff, I forgot to do one thing. Does anyone know what I forgot? I got to adjust the alternative hypothesis. I got 3 possibilities here. The standard deviation is not equal to some number, standard deviation is greater than some number, or the standard deviation is less than some number. Which one is appropriate for our data, our hypothesis test?
Less than 0.003.
So what should I choose here? Alternative 1, 2, or 3?
3.
3.
3. Thank you. Okay. The claimed standard deviation, what's that? Well,
Is that 0.003?
yes, that's your claimed standard deviation. You can get that from the original claim or from your null and alternative hypothesis, but that's exactly where that comes from, 0.003. So let's put that in. Sample size was 23, and the sample standard deviation was 0.0022. When that's all in, you can enter or press evaluate. It should give you something like this. What's the information that I need to get out of all this output?
You're looking for the p-value.
Yeah, we're looking for that p-value. Thank you. So p-value, in this case, is 0.03923. Probably don't need all those digits. And we're going to use that in step 5. Step 5 is where we make our decision. I do put some good emphasis on that part. We want to compare our p-value to alpha, 0.0392 and 0.10. Now, if it helps, you can add in enough zeros so that the length of this one matches the length of that one. Maybe it's easier to compare them that way. What inequality goes in here? A less than or a greater than?
Less than.
Thank you so much, Jillian. Less than. So reject H naught. Our p-value is less than alpha. That's the big thing that we wanted out of this. We wanted to know what the p-value is so we can decide to accept or reject. Last but not least, step 6. We need to state our conclusion in words. So for that, we want to look back to our original claim and understand what that was. There's your original claim. That sigma is less than 0.0003. So we're going to use that in conjunction with that sheet that I gave you regarding hypothesis, the wording, the conclusion. I think I gave that out in section 8.2. So it's this one. Let me clean up a couple old decisions here for us. That's not what I wanted. There we go. Let's see if we can't figure out where we're going to go, A, B, or C, in determining the wording of our conclusion. So I'll give you a second or two to think about it before we talk about the answer. Okay. Let's take a look at the first decision right here. Does the original claim contain the condition of equality?
No.
No. So that brings us down here on this branch. Do you reject H naught?
Yes.
Yes.
Yes. So that brings us to this branch, and we should use C as the model for our conclusion. So just copy it down exactly. I love the way that he's worded this, and he's made it very, very easy for you to try and get these conclusions right. So the sample data support the claim that. This is where you earn your money and your points. Sample data support the claim that standard deviation, and I want something a little bit more than is less than 0.003. Go back and describe the problem a little bit. What was this a standard deviation of?
Would it be in inches? Oh, pistons, of piston.
Widths is less than 0.003 inches. So that's pretty good consistency if you can get your, your widths down to, consistently below 3/1000ths of an inch. That's pretty good. All right. Now, somebody asked me in the last section, are you always going to see confidence intervals for this stuff in the output? And yeah, there is a confidence interval there. Do you think the confidence interval for the standard deviation here is going to include 3/100ths of an inch? Well, think about what we did with our null hypothesis. We rejected that null hypothesis. So if we reject that, should our confidence interval include that? What do you think?
No.
No, it shouldn't. Your confidence interval shouldn't contain that because we rejected that. We said, you know what, we don't think that sigma can actually equal 0.3. We reject that possibility. So when we look back at our confidence interval, hopefully we'll see that it doesn't. Now there's two different confidence intervals here. You want the one for the standard deviation. Can anyone explain this confidence interval below here? This one's for standard deviation. What's var? Give you a hint for something. Variance. Yeah, thank you. That's for the variance. So, we're doing our test with hypothesis or for standard deviation. You could also do something with the variance, but we did it with standard deviation. Now, there is a little bit of a nuance here that because of the way things are set up, this is an 80% confidence interval, which is twice our alpha, but at least the confidence interval doesn't contain sigma. So that's good. That is the 0.003. If you really wanted to be careful about this, you could go back and use your software to create a confidence interval at the 5% level. And then you'll get to the confidence interval that you wanted to look at. In any case, hope we're looking good on this one. Questions or thoughts on testing a claim about a population standard deviation for this? Let's do another one. And indeed, our last one. I'm hoping these will go a little bit faster. Would be example B from your handout. Here we go. Now, one thing that we haven't done in this, in either of these examples, is exactly test our claim, or test the assumptions that we actually have a normal distribution. We should be doing those. You can find a nice test for whether or not something is a normal distribution underneath. Was it data or is it analysis?
I think it's under data.
Yeah, I think it's under data. There you go. Normality assessment. That's where you can go to test your data to see if it's normally distributed. And it'll give you a normal quantile plot. It'll do a Ryan-Joyner test. And it'll also give you a histogram. So you should be able to decide for yourself if you think the data comes from a normal distribution. In the interest of time, And because of the problem, we're just going to say, oh, yeah, we got a normal distribution. So a simple random sample of 35 men from a normal distributed population results in a standard deviation of 12.2 beats per minute. This is for your pulse rate. The normal range of pulse rates of adults is typically between 60 and 100 beats per minute. If the range rule of thumb is applied to that normal range, the result is a standard deviation of 10 beats per minute. So, okay. Use the sample results with a 0.1 significance level to test the claim that pulse rates of men have a standard deviation equal to 10 beats per minute. All right, so we'll actually complete all those things that you'll be asked in my math lab by doing the problem out our way. So example B. Step 1, let's state our original claim. So what's the original claim in this one? Give you a hint, it's highlighted.
Is it 35 men?
Well, 35 men is something that we're going to definitely need here. But what's the claim?
Standard deviation is equal to 10 beats per minute.
Awesome. Standard deviation is equal to 10 beats per minute. And what's that say about the alternative then?
Not equal to.
Not equal to. Awesome. Thank you again. So step 2 is that alpha is, again, a big 0.10. That's pretty big. Now, somebody helped us out for step 3. Notice that there was 35 men, so that's good to know. We definitely want to know that. We also need to know the sample standard deviation. So let's look back here and see if we can't figure that out. What value should we be using for the sample standard deviation?
Standard deviation.
12 points.
0.1. Oh no, wait, that's a significance level. Sorry. Samples. Oh, it would be 10 beats per minute, right?
Nope.
Oh,
That was
Is it 12.2?
yeah, it's 12.2. So
simple
again,
random sample, right? Okay.
yeah, so if you look at this first sentence, it says a simple random sample of men results in standard deviation of 12.2 beats per minute. That's your S. So you might have to read through these things a couple times to find that. So the 10 beats per minute, that's really part of our null hypothesis. So let's go back and put that down here. That's going to be 12.2. And we'll use that to find our p-value. So we'll find our p-value by plugging it into StatDisk. Let me do that here. So analysis, hypothesis testing, standard deviation 1 sample. Before you forget, make sure you get the alternative hypothesis set up. And the alternative hypothesis in this case is the first selection, the not equal to. Significance level was 0.10. The claim standard deviation was 10. The sample size was 35. The sample standard deviation was 12.2. So all of that gets thrown in there before you can click the evaluate button. Bam, there you go. Now, what information am I going to look for from this?
P-value?
Yes, the p-value. So in our case, the p-value is 0.06663, like that. Which brings us to step 5. How's our p-value compared to alpha?
Less than?
Perfect. The p-value is less than alpha. Therefore, what should we decide?
Reject.
Reject. If p is low, h naught must go. So reject h naught. Step 6. Let's figure out which one of our possibilities we're going to use for the wording of our conclusion. So give me a second to pull that up again. There we go. And I'll clean these out. Why don't you see if you can't figure out for yourself and then put in the chat what you got. Put it to me privately. Which one of these, A, B, or C, or D, is appropriate to state our conclusion? Okay, let's take a look at the chat here. And a lot of people chiming in. I appreciate that. Let's see. Natalia, good job. Haley, you might want to look back at that a little bit more carefully. Bradley, Joseph, Carolina, Jillian, Joe, Rebecca, Soren, Alec, Jaleisha, Haley. All right, looking better. Everyone's looking good on that one. Well done. Thank you so much. So following along things, should go back and note that our original claim was this one right there, that sigma equals 10. So that puts us here on our chart. Does the original claim contain the condition of equality? Yes. Did you reject it? Yes. So that means we're going to start out our conclusion with this. There is sufficient evidence to warrant rejection of the claim that, now we got to state what that is in words. What was this data all about?
Men's heart.
Yes. Yeah. All right, so there's sufficient evidence to warrant rejection of the claim that the standard deviation of pulse rates, or you can say of heart rates, same thing, equals 10 beats per minute. Beautiful. Beautiful. All right. Now the confidence intervals for these do get a little bit tricky because they're not nice and symmetric like they are for the case of the mean or the population proportion. Those were nice and symmetric. In fact, on the handout, I believe you should have For population parameter, there we go. Where is it? I'm missing it. I had some other stuff here. Oh, this is the wrong section, that's why. Let me go here. So on the bottom of your handout, talks about these confidence intervals, and it also gives you a little bit more insight into finding these values. I think some of your older homeworks, you're asked to find chi-square sub r and chi-square sub l, and that much information is defined here at the bottom of that handout. So basically, you're trying to find these areas from these distributions with, 2.5% of the area in the right tail or 1%, and you can get that from StatDisk by going to analysis, probability distributions, and then chi-square distribution, and then plug in whatever you need there. So if you're looking for the area to the right of a chi-square value, there you go. And you can adjust that. If I want 97.5% of the area to the right of it, that's essentially 2.5% of the area in the left. So that would be chi-square sub L, or a particular value of alpha. Okay. Any comments on this one? Example B to wrap things up. Cool. I'm going to stop the recording here.